So the summary for this is test. Wow, my goodness, sorry, I almost said that like 6 times. Tests catch bugs before they reach production, but writing tests for every single function is time consuming. In this project, you'll build a GitHub Actions bot that watches your PRs,
So the summary for
analyzes new
this.
code using Python's AST module,
Sorry,
and
audio wasn't
generates
working.
PyTests
Audio wasn't working on YouTube.
using the Gemini API.
Yeah. So I had to test
So
it. Sorry.
again, like it really is just, pull requests happen. So you're requesting like some sort of
Audio is
change, you're
good.
making a
Okay, cool.
change.
Awesome.
And GitHub Actions goes, oh, you're making a change. Well, why don't I look through the code or like look through the changes that you're making and then invite Gemini to look at, the changes that you're making and automatically write tests that would make sense for your code and then run those tests for you. So isn't it so cool that really the thing that we will have to worry about most is just the change that we're making, and then GitHub Actions can cover a lot of the rest in terms of testing it.
Want us to ask Cloud Code how
So
to fix the audio?
we're going to be building this entire system. How do we build the system so things can be automated for us down the line? Okay, yeah, so our bot is going to use GitHub Actions to run a Python script that analyzes code, sends it to Gemini, and commits the generated tests directly back to your PR. Very nice. By the end of this project, you're going to have a Python script that analyzes code and generates PyTests. You're going to have a GitHub Actions workflow that commits generated tests directly to your PR. We're going to have Git operations that handle branching, committing, and pushing. And we're also going to cover coverage-gated test generation that only runs when needed. Ooh, okay. So, you're going to have your Python script. That's what we talked about here, that analyzes code. So this thing over here. Do you recognize the Python logo? There's the GitHub Actions workflow. That's this guy over here, the little... what is it called? Is this a gear? Yeah, it's the gear. And then you've got Git operations. It's not included in this diagram as much, but definitely the pull request is the closest thing to visualize it. And then we've also got coverage-gated test generation. So we'll see that in the secret mission. Yeah, so because it is the third project in the series, we're gonna just recommend that we do the first 2 projects of the series before you start this one. Every single NextWork project is designed to help you with just getting started if you haven't done the first 2 projects. But, the good thing about doing those projects is that we really go through every single step, like step by step with explanations and with like quizzes that you can do so that your understanding of each part of what we're doing is going to be much deeper. Nice. Okay, so we've got a quiz now. I am very excited to see how everyone fares with the quiz. The quiz is called AI Test Generation Bot. We're going to have 6 questions, and for every single question, I would love to see everyone's responses in the chat. So get ready to spam ABCD like 6 times. Let's take the quiz. Again, don't worry about having to know all the answers. This project is about learning the answers as we build, as we go. Okay, what commands are used within the GitHub Actions workflow to configure the identity of the GitHub Actions bot before it can commit changes? My goodness, Nick already has an answer before I finish saying the question. Damn. What commands are used within the GitHub Actions workflow to configure the identity of the GitHub Actions bot before it can commit changes? Is it A, git login and git set user? Is it B, git config username and git config user email? Is it C, the actions/checkout action automatically configures the bot identity? Or is it D, setting GitHub actor and GitHub email environment variables? Wow, this is a pretty interesting and tough first question to see in a quiz. But I would have to say, you might actually find git config user.name and git config user.email pretty familiar because you would have to run this in your terminal yourself when you're wanting to configure your Git identity in your terminal. This is very common when you have just installed Git and you're just setting up Git And when you just make your first few like commits and pushes, Git's gonna want to know who you are and who's like making this change. That's Git's entire purpose, to be able to track like changes in version history. So very quickly, like you might want to end. Nexus C is a possibility. Do we have any other guesses today? What do we think? So Git login and Git. I don't know. I don't know if we would use Git login for GitHub Actions workflow. I feel like that's something you would do to log in yourself, like through the terminal, and it's gonna open up like a verification code you have to enter and everything. Oh no, it's getting sus. The actions checkout action. GitHub actor and GitHub email? Environment variables? Wow, guys, this is interesting. All four seem like a possibility, to be honest. What if the actions checkout action automatically configures the bot's identity? Okay, I feel like we're all feeling equally like this is all possible. So, meeny, meeny, miny, moe. 1, 2, 3. Okay. I don't know. Should we just go for C and try? All right, Nick says C. Oh, it's not. So actions checkout does not automatically configure the Git user for subsequent commits made by the workflow. It must be done explicitly. Oh, well, at least we know now. It's B. Hey, it is. It is B. So the workflow explicitly uses git config user name and git config user email to set the commit author's identity. Very nice. Now we know. And which Google API is utilized in this project to generate meaningful PyTest tests? What do we think? Which Google API is utilized in this project? Generate meaningful PyTest tests. Wow. Well, we know that we're using AI in this project. Like we know we're kind of using Gemini AI to create tests for us. So, do we think it's the Gemini API? All right. Sean agrees that it's probably C. Roy is giving a smirk. Damn, very cool. So the project explicitly states using the Gemini API for AI-powered test generation. Question 3. According to the project, what is a crucial aspect of prompt engineering for generating effective tests with an AI model? Ooh, so if you've done some prompt engineering, this could be, you might have an upper hand. Is it A, only providing the function's source code without any additional context? Is it B, ensuring the prompt includes specific requirements and explicit instructions, like avoiding placeholder tests? Is it C, using only single-line prompts for clarity? Is it D, keeping the prompt as short as possible to reduce API costs? Well, I don't know. Do we think keeping a prompt really short is what's crucial for generating effective tests? Someone told me that, I'd be like, that's T, Like, that's interesting. Yeah, I feel like only providing the function source code without any additional context. I feel like A, C, D is actually just 3 ways of saying the same thing. So if they're all the same, and only one's different, what does that mean? Should we go for B? Yeah. Robot Glock from YouTube. Wow, it's been a while since I heard Robot Glock. Wow. I always laugh whenever I read your name out loud, and this time is no different. Great to see you. Yeah, so the project highlights that a well-crafted prompt tells the AI exactly what is needed, including specific requirements, explicit negative constraints, like do not do this. Do you have a handy tip for prompt engineering? Do you have your go-to? I think my favorite is still telling ChatGPT, like, please just stop being so nice to me. I just need some real like harsh feedback right now. But I'm feeling this one is about like being specific, which I think is a great tip. Okay, question 4. Oh, John is typing. Yeah, John has some mad prompt engineering skills. Oh my gosh. Punish me, GPT. Just as I say, you have mad prompt engineering skills as well. Wow. So, how is the AI test generation workflow configured to trigger only for relevant changes in Python files, excluding test files? Is it A, through a separate pre-commit hook that filters files? Is it B, by manually approving each workflow run for Python files? Is it C, using on-pull requests with paths and exclamation paths filters in the workflow YAML? Or is it D, by checking the file extension within the Python script itself? So how do we make sure that your workflow only gets triggered when you change certain files in your repository, in your project? Yeah, this is interesting. So we've got a vote for D, we've got a vote for C. Do we have a tiebreaker in the chat? What do we think? Yeah, Nick is also 50-50. But we know no one's really voting for A or B. Yeah, imagine if we have to manually approve each workflow run for Python files. Wouldn't that be so ironic? Like, yeah, I'm gonna use GitHub Actions to automate my work, and I'm gonna manually approve each workflow run. Okay, Amelia votes for C. I feel like that's a tiebreaker. Thank you, Amelia. Not all heroes wear capes. Thank you so much. And that is a success for C. The workflow YAML uses on-pull request to trigger on PR events and paths to specifically include Python files and exclude files within the test directory. Basically, what this is saying is in your GitHub Actions configuration, you can specifically say only trigger when I make a pull request that involves a change in these kinds of files. And you can just use some sort of filter to specify what kind of files that you want to include. Very nice. Question 5. What is the primary purpose of Python's AST module in the test generation script? Is it to A, manage environment variables for the Gemini API key? Is it B, to write the generated test to a file? Is it C, to convert Python source code into a tree structure for analysis? Or is it D, to execute the generated test? What is the primary purpose of Python's AST module? Now, I am not a pro in acronyms. Like when someone tells me an acronym, I'm like, I'm gonna forget this in 3 minutes. So we're gonna go out and we're gonna do that classic hover over this key definition or like this key concept. So an AST module is a Python module that helps you work with the abstract syntax tree, AST, of Python code. It allows you to programmatically, is that how we say that? Programmatically? Programmatically inspect, modify, and create Python code by representing its structure as a tree of objects. So that's cool. It seems like this module is helpful for being able to represent the structure of your Python code. So I guess if you have a lot of nested things, or if you have a lot of related things, maybe this is where the AST module is going to be pretty helpful. And it seems like this module is going to come in handy when we want to analyze our own code to generate tests automatically. Perhaps this could be helpful because maybe an AST module helps with completeness, like it helps you make sure that you really check each part of your code, because it's going to be important that when we generate these tests that it really covers like all the different parts of our changes. Anyway, that's my theory. We'll see. But yeah, it looks like C is the right one here. Okay. And the last question is, why is skip CI included in the commit message when the bot commits generated test? To mark the commit as originating from an automated bot, Is it to prevent the AI test generation workflow from triggering an infinite loop? Is it to indicate that the tests are still under development and should not be run? Or is it to ensure only the CI workflow runs on the generated tests? Why is skip CI included in the commit message? Wow, again, like this is probably something that we're going to understand a lot more when we do the project. So it's okay, we don't have to hang around this question for too long. But I'd imagine the bot is trying to commit generated tests. So the goal of a bot committing the test is to make sure that it runs and that it runs properly. It just runs the test that it's created. So why would you skip another workflow? Because skip CI basically would suggest that you're skipping another workflow. And for context, CI is actually a workflow we created back in like project 1 of this series. So we're actually skipping an existing workflow. So we wouldn't be skipping a workflow to mark a commit as originating from an automated bot. That would be a bit interesting. Is it to prevent the AI test generation workflow from triggering an infinite loop? Is it to indicate that the test is still under development and shouldn't be run? Or is it to ensure that only the CI workflow runs on the generated tests? Okay, I feel like these are pretty equal. C is interesting, like the tests are still under development and should not be run. That's a hot take if CI is actually a workflow we created in project 1. So it could be between B and D to ensure only the CI workflow runs. Why don't we just do eeny, meeny, miny, mo? I think it's B or D. Let's just go for D. Let's try. Oh, Amelia's typing. I'm just gonna wait in case Amelia has a suggestion. Okay, all good. Oh, Amelia says B. Okay, we'll try B instead. Oh, great. Look at that. Nice work, Amelia. So skip CI tells GitHub Actions to ignore specific commits for workflow triggers, preventing the bot's commit from re-triggering the test generation workflow. Okay, so we're basically trying to prevent infinite loops by asking GitHub Actions that if you were to trigger this workflow, can you please ignore the other workflow? Because maybe like if you were to trigger the other workflow, they're just going to start triggering each other like forever. So we'd want to make sure to ignore one. Okay, well, thanks everyone for doing that quiz. I'm so excited to just get into it with the project. So what are we building in this project? We are going to build a way for GitHub Actions to generate tests for us. Not yet. We're going to build a way for GitHub Actions to generate tests for us on every pull request. This is using well, it's going to definitely use GitHub to trigger the GitHub Actions workflow. And also the Gemini API to generate tests for my code. Our code. This will help us save time on writing tests for every single function of our code, as that would be time intensive. So I think that sets our intention for this project. Okay. All right, so let's just create that test generated script now. We are going to make sure from parts for parts 1 and 2 of the series functions. Cool. And then we're going to send function signatures to Gemini for test generation, which is going to help us with writing generated tests to a test file. Okay. Whoa, what is a function signature? I was literally just thinking that. I was like, I cannot pretend I know this one, guys. So a function signature is a concise summary of a piece of function, which is a fancy name for a reusable block of code that performs a specific task. It tells you what the function is called, the name of the function, what inputs it needs, like the parameters, including their types, and the kind of output it will give back, which is the return type. Okay, so what this is basically telling us is we're going to create a Python script that's going to read our code and extract all of the functions in that code. Because our Python, I would say our code is made up of our app code is made up of a lot of different functions. And to properly write tests, we're probably going to want to attack them function for function. So what we're going to do is we're just going to pull apart all of the functions in our code so that each one can be sent to Gemini individually for Gemini to generate the correct test for it, or the best practice test for it. And then all of those tests that Gemini creates is going to automatically save in a file that gets created as well. So that feels like a nice and chunky step one. It's a great way to just get stuck into it. Okay, so in this step, we're going to write a test generator script. So we're going to write a test generator script, which will, what is the script going to do? Do you remember? We just talked about it. This test generator script is going to extract the functions of our app, or in our code, in our code, and then it is probably, I'd imagine that's how it's going to use the AST module that we talked about just now. And then once the functions are generated, Gemini will be used to generate tests for each function. This is important. Yeah, this is important. Because well, first of all, this is like the script that we're trying to automate. So if we didn't have the script, we wouldn't have much to automate, would we? That's a very straightforward way to think about it. But why else is this important? Well, it's also important that we, kind of pull this apart, function for function, so that we are really like looking at the entire piece of code. So it's exhaustive, it's complete. So maybe this is important to make sure that our tests are complete, i.e. it addresses all the different parts of our code, not just, a few key parts, a few key bits, a few key functions. Okay. Have you done part one? This is probably going to change the course of this project for you, because if you haven't done part one, that's totally fine. Like, the steps for catching up are all in here. All you got to do is switch tabs. Like, damn, look at that. That's very nice and smooth. And it even goes all the way from like, do you have a GitHub account? And it really will take you through how to basically set up the foundations of this project. For me, I have completed part one so that we can get straight into the meaty content for this project. So we are going to just use this tab today. We've completed part one. We're just going to make sure that we've actually got these things, though, to be confident. And that's a great idea. First things first. Do we have our forked AI CI/CD GitHub repository on GitHub? I sure do. So it's over here. I've got it ready here. This is the repository that I forked in project 1 of the series. And is the project cloned locally in Cursor? It definitely should be. So I'm just going to open up Cursor now. Oh, it's already open here. We'll ask everyone, if you can still see this. Ooh, I think I just stopped the entire thing. But whoa, buzzy. Let's see if you can see this. You should be able to see that I've got the project cloned locally here. If you're wanting to learn how to do this, you can, let's say I'm just gonna quit cursor completely so I can do this from scratch. And how we can get there is by, once you've got cursor open, you can click open project here in cursor, and then you just click on the folder where you have saved your work. So AICICD GitHub is the name of that folder, so we're going to click open. And here we go. That's your project ready to go in cursor. Very nice. Also chat, let me know what you think. Would you prefer I split my screen now? So that half the screen is the project guide and the other half is cursor. So I'm doing less of this like switcheroo thing. Or would you prefer you like seeing the full screen experience of both things, of the project guide and of cursor? In that case, I won't split my screen. But there's probably going to be a bit of like back and forth, by the way, you know. For example, we're now just going to double check that we've got a working CI workflow. So we're going to go ahead and just double check that in the workflows file, that there is the CI YAML file. Okay, so you've got it. If you see it, that's perfect. If you don't see it, no stress. Again, the steps for that is all in the other tab. So you'll be all good. Okay. And next is, what about part 2 of this project? So if you've completed part 2, you are obviously a very organized and prepared person. We like that. Stop! Damn, this project's flirting with me. No, I'm joking. So one more quick checklist reminder. Do you remember creating your Gemini API key from Google AI Studio? Yes. I would show it, but I feel like I will get told off right after this stream if I showed that key to you guys. But you can definitely find that key in Google AI Studio if you've created it. Wait, is there anywhere I can show you the UI for this? So we could do a little dance and not show you the API key, but you could still kind of know where to find this yourself. Let me see if I can do a little something, let's see. I think we can do a little something. Yeah, this is fine. This is totally fine. I hope the team isn't sweating as I do this. So this is, Google AI Studio, and you are able to create API keys in Google AI Studio. It's literally aistudio.google.com/API-keys. And then once you're there, you can create an API key on the top right. And then there are steps for creating that key too in the project guide. But I can definitely see that I have my key, which is called Natasha AICICD code review. That gives us the confidence to just tick that and know, yes, we do have that API key. It is alive and well. And then do we have the Google Gen AI package in your requirements text file? This is a great one to check because if you don't have that, what's going to happen? If you don't have that, it probably means that when you're trying to run this project, you won't run this with the Google Gemini AI API. We wouldn't be able to use that in this project. So definitely make sure it's actually in your requirements file. And then do you have the AI code review script, which is nested under the scripts folder? Let's have a look. Can we find a scripts folder? Yes, we can. Can we find AI_review? Yes, we can. It is looking fresh. This is looking good. This is a file that we created in project 2. So good to see it's still alive and well. Very nice. And then do you have your Gemini API key stored as a GitHub secret? So this was a great step. Shout out to project 2 for this. We learned that in the settings of your repository, there is actually a way for you to save API keys as environment variables. Again, I'm just gonna double check that it's okay. Yeah, I've already clicked on it. And thankfully it is okay. The repository secret is saved as Gemini API key. The value of it is hidden. And then that means we can confidently tick this off. We got this. And then last thing to check is if you've got the PR review workflow. At GitHub Workflows PR review YAML. Okay, so it is under the GitHub folder under workflows, and it's called PR review. So we've got that too. Perfect. So I think we've got everything we need to keep going. As I kind of flick back and forth, I'm sensing that actually just a split screen might be better for us today. And shout out to Nick and Amelia mentioning that the NextWork UI UX is really starting to grow on me. I'm glad I'm joining these sessions with you guys. Thank you so much. Amelia says, yes, UI is honestly so easy on the eyes and great to use as a user. Thank you so much, both. My goodness. Yeah, I can see that John is glowing with the feedback as well. Absolutely, a lot of thought and effort goes behind it. Is there anything you'd like to see for an even better or even more wow kind of UX UI? Has anything popped into your mind in terms of like, hey, it'd be nice to have this too? Definitely add them to the chat if if something comes to mind. Okay. I think with everything checked, we are ready to create the test generator script. So I'm gonna adventure into splitting my screen and see if this is gonna be easier. Otherwise, it's gonna be swapping back and forth quite a bit. Okay, I hope this looks good. And we're going to, in cursor, select File, Open. Okay, we've already got it open, so that's good. In your file directory on the left, right-click Scripts. We're going to right-click on Scripts. And we're going to select a new file. We're going to create a new file, and we're going to call it generate test.py, so that it's a generate test Python file. Nice. We're about to paste in a whole bunch of code. Here we go, everyone. Here we go. Let's understand what we want it to do first. This code is going to read a file of code and identify different code functions so we can make tests. So again, this is going to create tests for us. How it does that is it reads your app's code and it pulls all the functions inside it, function for function. It reminds me of people saying band for band for some reason, but every single function gets pulled out. And here we go. Have a go at filling in the blanks for this code block. Oh, let's do this together, team. Wow, there are a decent number of things that we can fill in ourselves. Let's give this a go. So first, we're going to define a function that takes a file path and extracts the function's information. So let's define, what would you name a function that extracts function? If it's really up to me, I would call it functionception. I don't think it's, I don't know if that's appropriate today. What would you name a function that extracts function? Honestly, extract function. Surely, guys, surely. Functionception, right? And what are you passing in? So this is a function that takes a file path and it extracts the function information. So I love that these comments do drop in some really handy tips for us because, we just called it extract function because this is literally all it does. And let's name functions based on its purpose, like what it's here to do. And the purpose is to extract functions from a piece of code. And how it does that is it takes a file path. So what are we passing in is basically, what is the function going to need to take in order to do its job? In this case, it's going to pass a Python file, but it's really just trying to take a file path. And it's going to pass the file once it's got it. So let us say that we're going to pass it a file path. That's what it needs, right? That's all it needs to actually do its job. So let's give it a file path. Okay, we're going to open the file and read its contents into a string. So here is a little bit of a... Oh, so this is saying we are going to open the file that is at the file path you defined, and we're going to read the file, that's what the R means, as F. Okay, so source is, okay, so we're going to say, what is the source of the file that we're reading? Oh, actually, what is the file's content? How do we extract that? Do we go like F? We're going to read the file at F, so do we go F dot read like this? We shall find out. Let's find out. And then we're going to parse the source code into an AST tree. The tree says, what AST function parses source code? What AST function parses source code? Let's find this out. Interestingly enough, once we've got the source code in an AST tree, that tree is gonna, like, every single node in that tree, so every single function in that tree, is going to be read and then added to something else, it seems. Okay, so what AST function parses source code? Honestly, do we know this? Is this existing information, team? Have I missed something in the project guide? Hey, let's find out. Nothing to stress about. It's never here. I was going to say Maya is here, but in this case, Maya is enlisting ask. Ask is here. And we're going to just ask what AST function parses source code, and please be concise. While it's doing that, check if this node is a function definition. Okay. Oh, wow, that was very, very quick. Thank you very much. So the AST function that passes source code is called ast.parse. So let's give that a go. What does parsing mean? Do we know? What does parsing actually mean? Can we be concise? And then let's have a look. Okay, so parsing is basically the process of analyzing a string of symbols in natural language or computer language and converts that into a format that can be processed by a computer. That sounds very essential. So we're going to parse the Python file. We're going to extract all of the functions in there. And, oh, there we go. And we're going to check if this node is a function definition. What AST type represents a function? Wow. What do we think? Let's see. What AST type represents a function? Be concise. So the AST type that represents a function is AST function definition. Interesting. So let's add that in here. What do you think? I hope this is okay. Kahoot typed in the chat for a second and I was like, oh my god, he's gonna be like, nah, what are you doing? But let's see what's going on. This code enables us to read a file, identify functions, and then store them in something called an AST, the abstract syntax tree. Instead of reading code as text, the AST presents it as a tree structure where each node is an element of the function. And Kahoot says make sure to read the new Python concepts banner. Okay. Okay. We have filled in the code blocks. The new Python concepts banner above it. Maybe it's here, maybe it's coming soon. Okay, we'll look for it. We'll look out for it. Okay. And we're just going to also check out whether or not what we filled in looks right. Let's have a look. So we're going to define the function called extract functions, and it's going to take in a file path. So I think we got that right, extract function in file path. Except that it does use the S, extract functions. So shall we just make it a complete match? And then we are just going to make sure that we're going to read the file, and it says f.read is how you do it. So that's pretty good. F.read is right here. And then we're going to pass the source code into an AST tree. So these are things that Ask supported us with. Thank you for the assist, because I think it's almost right. We got some things slightly off here. So we're gonna actually need to go ast.parse and actually just parse the source code which you need to put inside the brackets. Otherwise, it's not parsing anything. So let's just make sure that's in there. And I think that gives us everything we need to actually bring this code into our generate test file. Shall we go for it? Okay, I think we're ready. So let's go ahead and paste that in here. And then let's save that. So I think we're looking good. How's everyone doing? I know we've got a few people that's doing this project with me. Where are you guys up to now? Are you ahead of me? Are we wanting to spend more time explaining things? Let us know how we're doing. Okay. Okay, so now that we have uploaded that, now that we have copied that code over, I think we're ready to answer this task, which is to upload a screenshot of your extract functions code. Oh, it's just the extract functions. So well, let's just make sure we zoom in on this one. So it's just the extract functions. Ooh, okay. Let's go. Let's go. And I think there's a bit more, but that's okay. And let us shout out to Krishna. I hope you're listening to this right now, my friend. Because you can hover over and just press Command V and paste in a screenshot or something that you've taken that's in your clipboard. I am addicted to it, like genuinely. It's like, one of those things where once you do it, there's no going back. It's kind of like that. Okay, so how does the AST module? Oh, much love. Thank you so much to Nick, Amelia, and Roy as well. Yeah, Sahib says, hover and paste feature is amazing. It is. Okay, so how does the AST module help parse Python code? Oh, this is a great question. I think it's great because there is a distance, there's a gap between my knowledge and my ability to answer this and this question right now. So let's close this gap by discovering more about the AST node. The AST module helps because, okay, we extract something from each function node. Okay, so we've got the AST module. Man, AST module, come out. Tell me how what you're helping us right now. So thank you for this little prompt for getting us to just go a bit deeper on figuring out why do we use an AST for storing functions. Okay. Man, I gotta say, if you don't tell it to be concise, it will be very detail oriented. So let's see. We use an abstract syntax tree for storing functions because it provides a structured hierarchical representation of your code rather than just raw text. This makes it much easier for programs to analyze, understand, and manipulate the code's structure and components, like functions. Think of it this way, when code is just text, it's hard for a computer to know what's a function, what's a variable, or what's a loop. I guess it is easier for us, especially with knowing where it starts and where it ends because of the visual things that we've got going, like the indentation and line breaks and all that stuff. So I'd imagine that if we didn't have that and we just saw like a smush of like text, it'd be harder to figure out what's going on. So the AST module is kind of like the computer's helper to help it figure out the different components of the code and what's a function, which one's a variable, what's a loop. Okay, nice. So the AST module helps because, so it helps parse Python code because it breaks down the code into a tree-like structure, which helps the computer identify, or like the computer system identify. Let's see, what do we think? It helps the computer identify what's a function, a variable, or a loop. So we extract. Well, we extract specific details, which I remember is called the function signature. And that contains things like the function's name, arguments, and even its source code. So we extract information or specific details from each function node, like the function's name, arguments, and even. So awesome. Now that we've got the code that is going to help us break up the, that is going to help, help us parse this Python code and generate tests for it, let us actually use this file to start adding a few tests. Well, I have a feeling though, what we've written so far doesn't actually go into the test generation part, which I now realize that's why we say add the AI test generation function. That's the next thing we're doing. But if we notice, just do a quick recap of our file. We've gotten up to extracting functions. But the goal of this entire file is that we extract the functions and we generate the test and we output that, like the test, into a new file. So there's probably 3 functions, I'd imagine, at least 2 functions to help us tick all of those boxes. So that means we're not really done with this file yet. We've actually got another function that we're going to add, and this one is all about sending the code that's been parsed to Gemini so that Gemini can go off and create some tests for us, and then it's going to send back the generated tests. Great. We will be pasting our new code directly underneath extract functions, and we are going to again have a go at filling the gaps ourselves before we check how this works. Very nice. So the okay, so here we've got what should you name a function that generates tests, and then look at what variable is used below, like function info. Okay, and then we've got create a Gemini client using an API key from environment variables. Okay, well, let's name a function that generates tests. Don't forget, how are we naming our functions, team? We're going to name it based on its purpose and what it's here to do. So let us call this function generate tests. And look at what variable is used below, like function info name. Okay, so it's telling us that, again, what is within the brackets when we define a function is basically what this function needs in terms of like information it needs, resources it needs in order to do its job. So we know that we are going to give this function the signature of this function, so the information like its name or the arguments that should be going through this function, perhaps even the source code of this function. So that is probably what generate test is going to need in order to work. So thank you very much to this hint that says look at what the variables are called, because these variables are again directly referenced later on in the same function, and we're going to want to make sure that it has a consistent name throughout. Great. We've got a few things mentioned here. So we've got function info name, function info arguments, which is basically like what are the actual things that function, whatever function that we've passed, what are the arguments and the resources that takes. And then we've got a doc string for the source code itself. So why don't we add all of those? Does that make sense? Let's just give it a go. What if it's just called func info like that? Maybe we actually just pass it like an array? Like a dictionary? Where, there are specific things like, there's a name, argument, docstring, and source. So we just pass it the entire thing, the function info thing, and then we just let the rest of that function to extract a specific part of what we've passed. Let's see if this is gonna work. And then we're gonna send the prompt to the model and get a response. So here we've got a pretty good prompt here that's saying, let's write a prompt that includes the function details and basically gives Gemini very specific instructions on how it should write its test cases and how it should write its tests. So let us write the rest of the code that's all about actually sending this exact prompt that's already been written for us to the Gemini model. We need to figure out which Gemini model we should use. Yo, that's a big ask. Damn, I gotta say, which Gemini model should we use? I don't know all the model names off by heart, I gotta be honest. But do you guys use Gemini models? Are there any models that you would recommend here? John says Nano Banana. Oh no, that's wild. Imagine if that's the Gemini model we're using. I'm gonna generate some crazy Avatar, Lord of the Rings posters when it's trying to just evaluate code. Which, you know what? That's a vibe. And we've got Nick suggesting Gemini 3.0 Flash. Kahu is suggesting maybe Gemini 2.5 Pro, and Gemini 2.5 Flash. Krishna saying Gemini 1.0. Well, you might know that Gemini 1.0 is probably I'd imagine, one of the older models out there. There's Kahu suggesting Maximus 0.5 Flash, which honestly checks out as a LLM name. Hey, which model are you using, Maximus? And I bet it'll be like a real trash model. Like, don't use Maximus. Bad model. Okay. Well, why don't we go with Nick's suggestion, Gemini 3.0 Flash? I would use Nano Banana, if only, but I think we'll get there one day, John. And what are we passing to the model? So, content. What is the content that we're going to pass? Well, do we think this prompt, once we pass this prompt over to Gemini can handle like the breaking up of the information we're passing it? Because I'm kind of torn, team. Like it could be either func info, like that's the entire content we give it, or it could be like, hey, you should actually just pass it every single piece of content separately. So func info like source, and then comma, and then the next one, and then the next one. What do you think is the right way to go about this one? Do we think it is just func info? Or should we break it down for it? Perhaps it's just func info. Nick is kind of suggesting a simple way to do this. And I think that's a great shout. Shall we give that a go? So Sahib says Roy 0.67 flash. Roy! Oh, I'd subscribe to that one. Roy, you are an LLM now. Great. Okay, so let's just return the text from the response. Return response. What property contains the generated text? You know what? Why don't we say text? Oh, not test. Text. Why don't we say that is what it's going to return? What do we think? Roy says I'm an RLM. I love it. Okay, so yes, it looks like we just passed func info into this function for generating tests. And it seems like we just passed prompt. I see. That's what you were trying to say the whole time, just the prompt. Ah, I see. So let us just actually correct that so that we're just using the prompt. Because we're just passing the prompt to the LLM. Oh my goodness. Absolutely. And then response.text. The rest seems pretty good. I mean, we've got Gemini 2.5 Flash. Wow, which was Amelia's suggestion. Well, Amelia, shout out to you. Oh, looks like I've completely ignored this one. So we need to figure out how we can get a Gemini API key from the environment, which is probably something to do with OS, I think. So if you look at the left-hand side of my screen, OS, I believe, is something that helps us with extracting environment variables. This is off of some rusty memory, but that's my take. Maybe it's OS dot Gemini API key. Let's have a look. Ah, very close. You have to use a function for retrieving the environment variable, but yes, OS is something that we would use to help us get there. Okay, very nice, team. I hope you enjoyed this. Well, I know I thoroughly enjoyed being able to just go through this piece of code like kind of piece by piece, and for some reason I'm trying to copy and paste just a specific part of the code block, but it's always copying the entire code block every time, which is kind of funky, isn't it? But let us just again. It seems like I still haven't actually copied it. Okay, it's not just me. Surely it's not just me. Guys, you can see this. I'm gonna copy one more time. Copy this. And then let's try paste it in here. Okay, and let's try paste it again. Oh, seems like every time we are pasting the entire function, which is kind of interesting. But at least we can just extract that. Okay, nice. All right, very interesting, team. Okay, let's go ahead and yeah, I think we're gonna go ahead and just put that, our new work of art, into our file, and let us save the changes as well. So let's go ahead and just save that in here. Yeah, you might have spotted. This is something that we talked about in our quiz, but there is some prompt engineering going on that tells the AI, tells the LLM exactly what you want with specific requirements, like give me 3 to 5 test cases or include edge cases. So that's awesome. Oh yeah, Nick and Amelia both say, yeah, this is happening to us too. Just trying to copy parts of a code block, but the entire code block gets copied. Well, that's something fun for us to look into. Thanks so much for sharing, by the way, Nick and Amelia. If anything comes up like this again, let us know. Let us know. Whichever channel feels right. Just pick a channel. Just say, hey, I'm seeing this, and you can trust us to handle the rest. Okay. Gotcha. Thank you so much, Nick. Shout out. And Maya says, "Ask Anything is the best channel if you'd like to keep it. If you'd like us to notice it straight away." So thank you, Maya. Okay. Wowza, it is coming together. So we can read files now with extract functions. We can identify functions now with the extract functions function. And then now we have also written the function for sending what we've extracted to Gemini. So the final piece of the puzzle is just to make sure all of this can be called by GitHub Actions later on. So that's the third function. So we're going to create this last function called main. Our final function main will allow us to call the rest of our script and pass in the changed files from a pull request. Oh, that's a nice way to tie it all together. And I think that's the thing about functions, right? Like, they can do some magical work as long as you call on them. And how do you call on them when you're just trying to automate this process? I see the importance of this main function. Like, it is there to make sure this stuff actually gets automated. Otherwise, if you don't have main calling these functions for us, these functions, as good as you've written them, it's not going to run. It's not going to work. So main is pulling its weight for sure. We've got more blanks to fill in, but let's see how we fare with these ones. Let's see. So main is going to get a list of changed Python files from command line arguments. So the changed files, how do you get all the arguments after the script name? So the change files, we're gonna get a list of the changed Python files. How do you get all arguments after the script name? What do we think about that? How do you get all arguments after the script name? Shall we use ask to help us with this one? Oh, next is anything past the first item in sysarg v. So it seems like we've kind of got sysarg v, and I see that sys is something that we have imported. So we are going to go sysarg v, and anything that is past the first item. So is it like 1 colon? Is that how we say anything past the first item? Let's give it a gamble. So now that we've done that, for file path and changed files, so for every single file that has changed, skip non-Python files. So if the file path is not Python, then we skip it. How do we check if it ends with pi? Wow, that's a good question, man. How do you check it? So let's use ask. I'm gonna call on ask. Let's help. Because how do you check if it ends with pi? Oh, again, sorry, I can't seem to paste that. So let's type it out. How do you check if it ends with pi? Please be concise. You can check if a string ends with pi using the ends with string method. Oh, cool. So let's just check if the file path, which is passed as a string, ends with pi. I see. So let's see if the file path ends with the reference py, the file path py. Okay. So skip the test files, skip all of the files that start with test. Does that mean it just means starts with, like this? Surely. All right, we're gonna gamble that too. Let's see. And then we've got print. So print analyzing file path, which means that we are just kind of printing a message to indicate that we are going to analyze X file path now. And off we go. We're gonna call our function that extracts functions. Yes, we did define that, didn't we? It's called extract functions. So this is the part where we're really gonna call on the functions that we've just previously defined to make sure we actually put them to good use. So the first function we defined was extract functions, and that is the first one we're going to call on. So we're going to extract functions. And then I see how this is all coming together now. So for every single file path that's been changed, if it is eligible for being for having its functions extracted, we are going to use the function that we've defined ourselves to do that. And we are going to also do something to every single function in that file. So I have a feeling, a file could have multiple functions in there. So now we've got a for loop that says for every single function in that file, we're going to do something else. We're also going to call the function that we've written that generates the tests. Great. So that means the function that we've written for generating tests is called generate tests. Nice. So we're going to go ahead and just paste that in here as well. So generate tests. So that means that we've got two for loops nested, like two for loops, one that says for every single file that's changed, let's extract its functions. And then before you move on to the next file, you do something for every single function that's been extracted. For every single function, you go, can you please, Gemini, please generate a Python test that's suitable for this function? I see. So that means that the extract functions that we've defined is for every single file, and then the generate test function that we've defined is for every single function. Interesting. Well, we've got one last thing to check. Only run this code when the script is executed directly. And it says if something equals main, then we just run the code. Then we run the code. Right. Well, I'm not too sure what special variable is going to equal to main when we run it directly. Do we know this? No way it's AST. Don't know if it's going to be OS or sys. What do we think? Oh, Nick knows. Nick says it is when name is equal to main. They rhyme too. Okay. So let's have a look. I think we're ready to check our answers now. So we've got sys argv and a 1 or more. So this is really just checking whether or not you've got files that have changed. And if you've got files that have changed, we're going to store all of them in like a tray, an array, which is cool. And then now for every single file that's been changed, we're going to double check if their file path ends with Python. If it doesn't, skip that file. Is that file inside something called tests? If so, skip that file. But if it sits outside conditions, then we should actually extract all of the functions inside and generate tests for them. So it feels like we've actually done pretty well, team. Ends with pi and starts with tests seem correct, except that I used double quotes, and this example only uses single quotes. So perhaps we should change this to single quotes. Does it make a difference? What do we think? And then extract functions is that function that we've already defined ourselves. So is generate tests. I believe we called it generate tests. So we're just going to keep the naming consistent for ours. Nice. And then the last thing is if name equals main. Okay, very nice. I wonder why it's name equals main. What does name mean? I'm so curious. Oh, I typed my question in the Discord chat. Very funny. What does... Oh, nice. Oh, looks like this has already been triggered, probably because of some sort of keyboard shortcut. it says here that the code block is a common Python idiom. It checks if the script is being run directly by the interpreter. If it is, the code inside the block will execute. Okay, cool. I wonder why it's called name though. What does name actually mean? Concise. My favorite two words whenever I use LLMs. Go. Okay. So I think we're ready to actually copy over our work for the main function. So let's go ahead and put that in our generate test Python file. It is becoming a party in here too. My goodness. So that means that we've got 3 functions in this file now. And I think that wraps up our work for generating tests. Great, this is good. Okay, cool. So I think we're ready to move on. Let's take a screenshot of the complete script. Let's do this. Ooh, should we take a screenshot of the complete script? Like the complete script? Does that mean I'm gonna do a micro, like, look at how long the screenshot's gonna be? Do you think it's gonna take up an entire page now because it's such a long screenshot? Let's give it a go. Let's see. Let's test the limits today. Let's see what's gonna happen. Oops. Okay. And then how does your test generation script work end to end? Well, I'm glad we've been talking through it slowly, because now we can say with confidence that the script works by first identifying which files have changed. Then it will qualify those files. So it will qualify those files based on whether it's a Python file and whether it is not in the /test folder. Files that qualify will then have all of their functions extracted, and each function will be passed through Gemini so that a test, a PyTest specifically, can be generated for it. Great. I think that looks good. So let's click done and let's move on to step 2. Oh, we're building the test generation workflow. So let's automate the test generation with GitHub Actions. You'll create a workflow that runs on every pull request, generates tests, and commits them back. Nice. We're going to get ready to create a GitHub Actions workflow for test generation. We're going to configure Git operations to commit back to pull request and prevent infinite loops using CI configuration. So it seems like in this step, we're going to try to automate what we have written, the script that we've written. And automation basically in this case means we're going to let it trigger itself. Like we're going to make sure that it knows when to run, generate tests. So let's give that a go. So in this step, we're going to automate a script we've written by creating a GitHub Actions workflow. This is important because the GitHub Actions workflow is how we'll actually get our script, get our test generator to run automatically, i.e., so we don't have to call it manually. Okay, so let's have a go at doing this. We're going to create the GitHub Actions workflow file, which is called testgen YAML. And then we're going to put all of this juicy details into our testgen file. So let's go ahead and do that together, team. We will do this by going to our GitHub workflows folder, and then we're going to create a new file and then call that testgen YAML. So let's go ahead and let's open up that file. Very nice. It's looking nice and empty. So it's ripe for adding in some details. And details it will get because we've got a bunch of configurations for the workflow already written out for us. All we got to do is copy and paste it. And it seems to tell us that on pull request, so when we make a pull request, we will run this testgen workflow as long as the pull request contains files that end with pi and do not start with tests, which is actually exactly what we've also talked about in the function, in the main function. So it's nice to see that it seems to be already pre-filtering that for us. Interesting. Okay. Well, we've got a few different components in this. Oh, I noticed my page is jumping around. Stay with me. We're here. Okay, so we're gonna see that when pull requests are open or updated, the pass filter makes sure that we only run when Python files change, and we are making sure to exclude those test files. Very cool. If we write tests for our tests, we'll get stuck in an endless loop. I think the quiz actually referenced that, eh? It referenced like why we skip CI. Maybe that's it. And there's some checkout configuration. Interesting. So this checkout configuration says GitHub. Hello? Where is this checkout configuration business? Here. GitHub head ref checks out the pull request branch, and it gets the full history for an accurate diff, which basically means an accurate view of what's changed in your pull request. What files have you created or changed, deleted, stuff like that. And then we've got our git operations. So we are telling, let's see, where are the git operations? I think it could be further down. Yeah, so you can see that we are automating the running of a few git commands so that we are extracting the changes, and then we are doing git operations like committing those changes and making sure we save them, basically. Interesting. So skip CI, which you might notice in here in the commit message. So the skip CI tag, is that in here? Yeah, so the skip CI tag is in a commit message, and it tells GitHub Actions not to run workflows for that commit. This prevents infinite loops because without skip CI, the bots commit would trigger the testgen workflow, which is another workflow we've written, which would generate tests and then commit and trigger the workflow again. So if you have a workflow that just gets triggered by, the updating of any file, then once CI is updated, then maybe your other workflow, which is testgen, is going to want to test the changes, and that file is going to change. And then CI is going to change in response, and then testgen is going to change in response. So I've got a few things that would happen if you let two workflows that can get triggered by each other to just trigger each other for all of eternity. That's pretty intense, guys. It's like a never-ending slide. So you just keep that's crazy. I feel like I don't know if you guys get nightmares about being in slides that just like never finish, but that used to like keep me up at night. Like I used to just wake up with a cold sweat, and I'm like, and it's because like it's just like the slide that just never ends. I don't know how that memory got triggered here, but all right. So why do we configure git user in the workflow? GitHub Actions runners start with no git identity configured. So Git is gonna say, who are you? Who are you to make a change? Show yourself. And GitHub Actions will be like, oh my god, okay, raise hand, it's just me, GitHub Actions, chill. So we have to tell Git who we are using git config username and git config user email. Can we see that here? Yes, we can. You can see that before we actually add, commit, and push changes, we try to tell Git who we are, so that Git can actually assign changes to a specific identity. So it's good to know that GitHub Actions self-identifies as GitHub Actions bot. Cool. So we've got our workflow file in here, and I think we're ready to just save it and then upload a screenshot. So that was nice. That was good to know. Do we feel confident about our understanding of this workflow file? Keen to hear what everyone thinks. If you could give yourself a rating out of 100 of your understanding or your confidence around the purpose and the reason why this file exists and how it works, chuck that score in the chat. I'd love to see it. That would be awesome. Okay, so let's go ahead and answer the next question. Oh, Roy is in the chat, by the way. If you're happy to put in your score, honestly, I would give myself like an 80. I feel like 80 is kind of high. I'll give myself like. Actually, I wouldn't say my number out loud. I feel like that's going to influence everyone else. Roy and Nick say 9,000 and 100. Wow. That's awesome. I love that. I love that so much. Shout out to you both. So the workflow triggers on pull requests where files with the file path. Oh, files where no, what am I saying? The workflow triggers on pull requests where Python files that are not in the test folder. Yeah, I feel like this sentence would flow nicer if I wrote it this way. So the workflow triggers on pull requests where there are changes to Python files that are not in the test folder. It uses skip CI because we want to avoid a never-ending testing, and we want to avoid a never-ending kind of cycle of two workflow files, in this case, CI and testgen, triggering each other. We wanna stop the cycle, end the cycle, and we end the cycle by just saying like skip the CI workflow file. Okay, so the bot commits by. How does the bot commit? How does a bot commit? Yeah, I'm getting philosophical when I ask questions like that. It's like a to be or not to be. The bot commits by. Well, it first shows itself, identifies itself using git config username and user email. And then it goes ahead and commits the changes. So why don't we do that? So we say the bot commits by adding its identity information, which is the name and email. And it will skip the CI workflow file while saving and pushing. The bot commits by adding its identity information, skipping the CI workflow file, while saving and pushing the tests it generates. So let's give that a go. I hope that's good. So I think we are now ready to commit and push this test generation script and workflow we've put a lot of time and effort into putting together. So let's do that. Let's run that. Okay, in our terminal. And that basically means that the workflow file we just created and the script that we've just created are now getting pushed into the remote repository in GitHub. So that's great news. And that is the end of step 2. So your code is now on GitHub and the workflow file should be ready. Shall we check our repository actually? So I know it's a little rogue. We haven't been asked to do this yet in the project guide, but let's do it. We can see, honestly, one of the things I love about GitHub, and I think it's underrated, is how easy it is to tell like when a change was made to a file. Like I think it's underrated because I don't know, like I actually refer to these timestamp things so much. And here we can see that a minute ago we have updated the workflow file, the workflow folder, and also the scripts folder, which is exactly the 2 files that we've updated. So that's good to see. Great to just confirm that everything was uploaded into our remote repository. So that's great. High five to you, yo. High five. I think that takes us to step 3, which is the last step of this project. So we're now going to verify that the tests run automatically. Aw, Nick gives a high five back. Shout out, man. We're going to create a pull request and watch the AI automatically generate tests for you. Cool. How we're going to do this is we are first going to create a pull request, and then we're going to watch the test generation workflow run, and we're going to make sure that AI has generated tests for your code. Okay, great. So we're just going to test that what we have created works on GitHub. And this is a 2-part thing. 1, can we make sure that we can even trigger this workflow that we have created? We're going to go test that. And we're going to test that by creating that pull request, right? Because here in our workflow file, we said that this workflow will be triggered on a pull request when you make a pull request. So we are going to create that pull request to put that condition to the test. Will you actually get triggered when I make my pull request? Great, so that's the first part. Let's see if we do that. And once it gets triggered, the second thing that we're going to want to make sure is that this workflow and the automatic generated test Python script that we've written actually works. Let's actually make sure that we actually get generated tests for our code. So that's the second thing that we're going to want to watch out for. So let's do this. All right, in this step, we're going to test our workflow and test script, should we say. So we're going to test our workflow and scripts by creating a pull request. This is important because it will verify 2 things for us. First, it's going to verify whether our GitHub Actions workflow actually gets triggered when we make a pull request. Second, it's going to verify. Whether the Python script for generating tests for our code actually works. Whoa, let's see how we fare, everyone. So we're really going to test basically these 2 files that we've been working hard on all project. One is this testgen YAML file. We're pretty much testing that in the first part. And then we're going to test our work on the generate test Python script in the second part. So this all starts by creating that pull request, creating that trigger. So we do this by creating a new branch for our code. We're going to do this by running this command here, git checkout b, new function, and then we are going to open our application Python file. So let's open this up here. So it's app.py, which you can see in the root of your project folder. So it's not hidden by any folder, subfolder, or anything like that. It should be at the root. Open up app Python file. Okay, so we've got a few things over here. Very nice. And we're going to add a new function at the bottom. This function uses recursion. I have not heard the words recursion or factorial ages. Wow. Do we remember what recursion and factorial does? Yo, I'm gonna phone a friend, man. Someone take me back to maths class. Take me back to school. How does recursion work again? This function uses recursion, a function that calls itself. Oh, okay. So recursion is a function that calls itself, and it's perfect for problems that can be broken down into smaller versions of the same problem, like factorial. Awesome. Wow, it's been such a long time since I last saw these words. That was like shock. Um, okay, so we are going to write the function that calculates a factorial of something. Okay, great. So we're gonna do this by checking how we handle invalid input. Let's just make sure the factorial isn't defined for negatives. Okay. And then we're gonna check a base case, make sure we stop the recursion when n is a certain value. And we are also going to make sure that we've got a recursive case. How do we make sure that this function will keep calling on itself? Nice. Well, I think the last part is probably the easiest thing to tackle. But you know what, team? Is there one that you're wanting to tackle and wanting to throw it out there? Hey, I think this should be this. Please add that to the chat. Would love to get your suggestions. Because I know for sure I don't know all of these, team. This is gonna be fun. Okay. So make sure the factorial isn't defined for negatives. And we've got Kahu in the chat saying, yeah, you do that by checking that n. If n is less than 0, we're gonna raise an exception. Okay. Okay. Raise, what is the exception for invalid values? Wow, should we make one up? Should we just make up the name of an exception? Invalid. No. What could it be called? Ah. Exception type for invalid values. No, I'm sorry guys, I'm drawing a blank. Drawing a blank. Let's just call it invalid. What if it's invalid exception? I feel like that's it. I feel like I've seen this before. Invalid exception. Okay. And then the base case. Let's stop the recursion when n is 0 or 1. So when n is 0 or 1. So when n, oh my gosh. Thank you, Nick, for calling out that the exception is actually above with this banner called New Python Concepts. It says raise value error. Throws an exception with a custom error message. Thank you. Let's use that. Value error. The base case says the condition that stops the recursion. Here we're going to make sure it's n. When n is smaller than or greater than 1, it will stop the recursion. Okay. And then we're going to return something. So if n is smaller than or equal to 1, we just return 1. Huh? Do we return 1 or do we return 0? Because 0 exclamation, surely 0 exclamation is 0. Surely? Because a factorial is 5 multiplied by something smaller than itself. So 0 factorial has to be like 0 times 0 or something like that. No, Kawu says it's not 0. Damn. Oh, wow. Nick is just throwing some great recommendations in the chat. And Sloth is here. Hi, Sloth. So good to see you. And okay, maybe it's 1 then. I feel a little confused. Does anyone have an explanation for how 0 and 1 factorial is 1? So interesting to me. Oh, Sloth is high net. Okay, so the recursive case is n multiplied by, this is a recursion we're talking about. We definitely need to call ourselves. So we're going to call factorial one more time. Let's just do it. Let's go return n multiplied by the factorial. Don't copy the whole code block. Damn. Let's just call factorial of n minus 1. I think this is it. I think we've got it, team. Okay, so let's check our answers. So if n is less than 0, raise the value error that factorial is not defined for negative numbers. And if n is smaller than or equal to 1, we return 1. And the recursion happens because we will keep calling on the factorial of n minus 1. And Kahu is a legend sharing the maths behind 0 factorial and 1 factorial. That's awesome. Thanks, Kahu. This is very interesting. So factorials represent the number of ways we can arrange n objects. And there has to be at least one way you can arrange one object. So, very fun. Okay, so wow, this is a lot of fun, team. I'm having so much fun today. Thank you so much, everyone, for being here. And shout out Roy for saying so many geniuses in this session. Yeah, we're in the presence of you too, Roy. So yeah, totally agree. Okay, let's save the file. I don't think we've actually copied this over, have we? So let's just make sure what we've written is actually in our file. Looks good. And then we're gonna save it and we're gonna commit and push our changes. So again, let's zoom out to see the bigger picture. Why did we do this change? Because we wanted to create a pull request. Why do we want to create a pull request? Because we want to test whether or not our GitHub Actions workflow gets triggered. So it seems like our next step is to make sure that we are making a pull request now, and then we're going to check whether or not the GitHub Actions workflow is actually going to get triggered. Okay, cool. Man, that factorial was such a trip. Like, it almost put my head in a totally different space, but we're going to stay focused, team. We did all that just to make changes in our app so that we can see whether or not GitHub Actions, that workflow gets triggered. Let's go. So we're going to set our fork as a default repository for the GitHub CLI. Let's run this command. GitHub repo set default. Which repository should be the default? So NextWork projects, this top one that you see is the OG repo that we all forked from in project 1. So let's not make that the default. Let's make sure that if we are trying to make changes to the repository, we're going to try to change our own copy, which is the fork. So my GitHub username is Natasha Ong is coding, so that's why it starts with that. So you will probably see your own GitHub username here, and then /AICICD GitHub. So let's enter that. Nice. So this is now our default repository. I noticed that we haven't really explained why we're setting a default repository, but my guess is we're going to run some special commands now, and we're going to want to make sure that those commands are automatically pointing towards our repo. So let's see what commands we're going to run. Okay. Okay, so this is the command. We're now going to create a pull request within the terminal. I feel like this is a first in the series because even I am a little bit more familiar with creating pull requests from GitHub, the web app, instead of using a terminal. I'm more used to the browser. So we're now going to actually use a command for creating pull requests. Very cool. So we're going to test it we're gonna call it add factorial function. And the description should say testing AI test generation. Seems like the command ran fine, so that we've got a pull request that we can go check out. So let's have a look. Let's go and check our pull request. Okay, I'm gonna refresh that. Okay, so we've got add factorial function. Pretty sure that was the title that we just defined. So looks like it all worked okay. But we do have a failing test, which, not nice to see, not a pretty sight, but that's okay. It looks like code review and CI build are working fine, but generate test is not. So it seems like that's failing for us. So we've got an error. Houston, we've got a problem. Let's see. Let's see why. Why? Check that. First, let's just check that the workflow file exists. Yep. The Gemini API key is set correctly. I think if it was set wrong, this wouldn't have worked. The code review wouldn't have worked if the API key was wrong, because that API key is also used in this other workflow file. So we know that the Gemini API key isn't the problem here. But we do still have an error. Seems like we should be able to just click on this failing check and just see what happened. Okay. There was something wrong in my code. It seems like we've got an unmatched closing bracket, and that is the reason for the failure. Wow. What a great way to find out that you've got an extra closing bracket going on here. And that is in the generate test Python file. So let's go ahead and open the generate test Python file. And let's go ahead and close up that, there we go. Let's close up that bracket. Sorry, let's delete that extra closing bracket. Do you see how that just causes a mismatch? Because we really need an equal number of opening and closing brackets in this line, buddy. And here we've got an extra closing bracket, and that seems to be causing the error. So let's go ahead and delete that and save our changes. Perhaps that's it. That's all we got to do. So let us speed run a new commit and push. So let's commit fix typo and generate test. Let's push that up. And then shall we just try create a PR within the terminal one more time? Since this is our new skill unlocked, why don't we do it one more time? So we're gonna call our new PR next generate tests, maybe? And then let's just put that. Let's see. Oh, a pull request for the branch into main already exists. Oh, that's true. We don't need to create a new pull request because I didn't merge anything yet. This pull request has not been deleted yet. So the changes that we just made should go straight into this existing pull request. Okay, so no new PI needed. In the meantime, we've got Nick in the chat saying, "Hey, yo, mine is saying the code diff is not being passed to it." Is this an error, Nick? Shall we go check this out? Oh, Nick, you are doing this project exactly like where I'm at too. This is so fun. We're truly doing this together, aren't we? Aw, hey, that's awesome, man. So let's pull up Nick's pull request. I hope you don't mind me blasting this to the stream. Let's check out Nick's pull request. And it's the same as mine. It seems like generate tests isn't working, but yours is slightly different. This is definitely a different error message. Oh, this is fun. Let's all have a check out Nick's error message together. Let's see. It says here, Google Gen AI errors 404 not found. Well, it seems like they're giving us a hint here, Nick. It says here, Gemini 3.0 Flash is not found for our API version. So it looks like the API it looks like the LLM that we're using is not the best one for our generate tests script. You might notice that line 66. Yeah, I would definitely check out line 66 and correct that to Amelia's suggestion for Gemini 2.5 Flash. Please let us know how it goes. Sending you all the luck. If anyone's hearing this right now, please send like a 4-leaf clover in the chat for dear Nick. Let's send a loaf clover. I'm sure that's gonna get us through. Okay, so let us go ahead and head back into our project. Generate test is still failing for me too. What's happening? What's happening? We've got another error. Oh, I think we've reached we hit some sort of quota for, yeah, Gemini 2.5 Flash. That resource is exhausted. Quota exceeded. All right. Looks like this model is struggling a little under the pressure. So shall we try something else? Shall we just try something else, team? Should we just use another model? Just thinking out loud, if it feels like Gemini 2.5 Flash is a bit overwhelmed, why don't we try another model? So, how rate limits work. Thank you very much. Let us see. We've got. Aw, hi Brandon. Brandon's in the chat right now. Hey, good to see you. Okay. Should we just try another model? Why don't we use ask? Okay, why don't we do that? So let's just let ask know. Hi, buddy. We are running into errors with using the Gemini 2.5 Flash model. Can we please try another one? Or is there a better solution? And you know the magic words. Magic 2 words, be concise, team. Okay. Let's see what happens next. It looks like you've hit a quota limit for the Gemini 2.5 Flash model, which is common on free tiers. The immediate solution is to wait for the specified retry delay, about 30 seconds, and then try again. Oh. Maybe waiting is the better answer. Okay. Should we play the waiting game? I feel like we've done 30 seconds now, though. Don't you think? Am I being greedy? Should we just try run this one more time? Let's try run it one more time. Rerun. A failed job. Let's try this. Oof. I hope this works. Cool. Do you think it's gonna work now? Oh, and just calling out that I know we are going a little over time, so I know we're at the very last bit of step 3 now. So I think we're at the finish line. You know, I'm feeling confident that we're at the finish line. It would be nice if we could do the secret mission though. It seems like a very special one. So should we, while we wait for this, we have the same error. Okay. Let's just say that it says resource exhausted again. Shall we just try a different model? Surely. Surely. Surely we just try a different model. What do we think, team? Change it to the model Gemini Pro. Do we think Gemini Pro is a good one? Hopefully it doesn't have hopefully it actually works because seems like Gemini Pro 3 didn't work. So maybe I'm gonna scroll back up in our chat. I remember we've had different kinds of recommendations in the chat. So, like, maybe we can replace Gemini 2.5 Flash with Gemini 2.5 Pro. Let's try this. Okay, let's go. It's the worst that could happen. Team, git add, git commit, change, Gemini model. Gosh. Okay, let's see if this changes things for us. Nice. Nice that you get a free year of Gemini Pro as an American student. My goodness, with a .edu email. Cool. Okay, we've changed our model now. I hope this doesn't cause any trouble. Let's go ahead and see whether add factorial function is going to work. Sorry, I am so distracted by the fact that this worked 8 minutes ago. How did it not work and then work? 8 minutes ago? That's pretty recent though. I feel like that means it was in one of the latest pushes? Oh. It seems to be working. Oh, never mind. Add factorial function is the title of the PR. Okay, so it was actually just running the CI? Oh, no, it wasn't running the CI workflow. It was running a workflow. Okay. Yeah. Bad luck, team. It seems like if I change the model, we actually have AI code review fail as well. So now we've got CI that's passing, but AI code review is failing, and so is AI test generation. So both of them are failing. Before then, it was just test generation that was failing, but now code review is failing too. So maybe changing it to that model was not a good idea. Oh, I've exhausted that one too. I'm exhausting a lot of things today. Oh, for some reason it still says Gemini 2.5 Flash. Please retry. We didn't actually update it to Gemini 2.5 Pro though, didn't we? Oh, could it be because it's actually AI review? Yeah, it's probably because it's still being used in AI review. Yeah, Gemini 2.5 Flash is still being used in the other script. So maybe we change this to Gemini 2.5 Pro. And then let's go ahead and check out what's wrong with the other workflow. But this is all very interesting stuff, guys. This is all very interesting stuff. Let's figure out what's going on with our other workflow, which is on test generation. Let's see what went wrong here. Any guesses, team? Any guesses? Okay, we have exhausted Gemini 2.5 Pro too. Yeah, I think we've got a great suggestion, honestly, from Brandon and oh, sorry, from Shane. Perhaps we upgrade our API key to billing in Google AI. Yeah, I know, so rude with the rate limits. Maybe we do that because these quota failures is probably gonna keep happening for the other models too. Okay, let's just do that. Well, I am just going to open up Google AI Studio and I will go ahead and upgrade probably the quota tier from free tier to something else. So let's set up billing, which I will do in a separate tab, in a separate window. But yeah, let's just go ahead and let ourselves use a little bit of coin with this one. Shall we try it? Okay, I've linked it to a billing account now. Do you think it's instant? Maybe I'll be able to actually run this workflow again. Shall we try that? Yeah. Okay, let's try it. Let's go ahead and run that. Can you please rerun? Yeah, let's just try rerun it. Can you please rerun? So rerun all failed jobs. All failed jobs. Go. Let's do it. And the other one also needs to be rerun, doesn't it? So let's also rerun AI code review. Do we think it's gonna work now? I hope so. Let's see. And even if it doesn't work, we'll figure it out. Roy gives me the coin emoji. Yeah, because we're chucking some coin in now. We're putting in some investment in this one. Let's see. Actions. Oh, amazing. Oh, wait, never mind. I thought it worked, but actually this is the one that worked like ages back. These two are the ones we're a little bit more nervous about. Let's see whether or not we can actually run these workflows, and whether or not these jobs will run correctly or pass fine, now that we have also given ourselves a paid billing account behind the API key. So the theory is, previously these workflows would have run fine if it's simply just blocked by some quotas, by some rate limits. And because of those rate limits, that's the full reason for the failure. So we've decided to just solve that problem by giving ourselves a paid API key. And we're saying, all right, with this paid API key, we should not have the same rate limits. So if this still fails, even after we've given ourselves a paid API key, that does tell us it's probably there's something else that's going on that we need to fix. It is nice though that AI code review has already run and fully passed, which tells us that at least that has solved it for the AI code review. Cool. Well, I'm gonna drink some water while we wait. What do you think? Ooh. I'm loving that Nick is also chucking some work that you're doing in the chat. I decided to create a second PR on my repo for a different function, the Fibonacci. But for some reason, Gemini is not generating tests for my new functions. Hmm. This is interesting. I'm very keen. Okay, well, okay, first things first. This is working now. So at least I think we've finished the project with that, now that we've seen that it works. Hey, thank you very much. Thank you, Roy, for the winner chicken dinner. I agree. I'm also hyper curious about what's going on with Nick's PR. So all checks have passed, which is a great thing, but Nick is suspicious. Why are there no tests being generated for this new function? Let's find out. So it's nice to see that you've updated the model from 3.0 to 2.5. Glad that it's working for you now. And then you've defined factorial. Okay, awesome. Oh. You've defined factorial, and then you've defined Fibonacci. Okay. For something in range 2n, ab equals b, a plus b, return b. What do we think is happening? Yeah, okay, it seems like we've got a similar kind of experience for Amelia, because the action passed for me, but no test has actually been created. Let's see what's going on, team. Let's find out. Generate tests. Successful in 2 minutes. It seems like tests are being generated. This points to yes. I mean, let's actually check my my workflow run as well, just to double check that this is okay. Interesting. Let's figure out what's going on. So we've got AI test generation going on in my workflow run. It finally ran successfully. Yay. And over here, it seems like we've got tests written to somewhere and then commit. Ah, okay. And this is what Pano is also calling out. No new tests generated. How could that be, team? Well, why don't we first check out the workflow file that we have created to understand what it is supposed to commit. So, commit generated tests. So we've got something that would trigger that message. If git diff -- quiet tests, then echo no new tests generated. So if git diff -- quiet, maybe something's going on with this checking. Git diff quiet seems interesting. Why is this passing? It- could it be because the path says we exclude anything that's created in tests? Well, no, it's not that test is a problem. We actually have the scripts here. So why don't we explore, let's see. But the interesting thing here is it seems like we are able to gather that tests are being generated, but they're just not being committed. Open the drop-down on line 1 of generate tests. Ah, this one? Okay, you know what? We're gonna zoom in because this is a group project right now. Let's do this together. So we've got Python scripts generate tests. And Pano mentions that this is the command. Right. It's passing in the test script as the argument. Cool. I mean, it's interesting that we've got script / generate test pi twice. Is that interesting? What does that mean for us? Let's have a look. Well, run Python. Oh, okay. This okay. There we go. So this is what's going on. Run Python scripts / generate test pi, and It is saying that the two files that have changed are the app file, and the generate test file. Okay. That seems to be correct because those are the files that we did change in our latest in our PR. And then we've got extra work going on here. Test generated, written to this file. Hmm. Hmm. I wonder if something is going on. Test generated. I have a feeling something's going on with this. Like for some reason, git diff quiet test is triggering something. So I'm keen to understand this. When does this get triggered? Like, why is this condition being fulfilled? Let's understand this. What does this mean? Git diff quiet test mean? When does it get fulfilled? Why is it being fulfilled? Even after the workflow has generated tests for us. Oh, sorry, my screen is a bit buzzy right now. Oh, let's try. Okay. Why is it being fulfilled even after the workflow has generated tests for us? I'm suspicious of that. I'm very suspicious of that. I wonder what's going on. Oh, we've all got our suspicions, don't we? I think the hunt is on. We will find out what's going on. But if me, Amelia, and Nick are running into something, I really think that maybe something's going on with the workflow file. Okay. So the quiet flag suppresses all output. And communicates the result via its exit code. If there are no differences, meaning the test directory in your working copy is identical to what's in the index, it exits with a status of 0. Success. If there are differences, it exits with a status of 1. Failure. So that is pretty interesting. So what does if git diff dash dash quiet test slash is that implying if it equals to 1, then something happens? Oh, we've got some activity here. Yeah, I think we're coming into the same conclusion, team. We're all thinking similar things. Um, so we've got Amelia mentioning I had to change that line before git diff dash dash quiet test checked before staging, which could miss new files or changes. Stage first with git add and use git diff cached quiet to detect changes after staging. Hmm. Oh, and you've added way more than just a couple lines. Actually, it's we're adding we're adding a decent number of lines. And we've also got Nick jumping in with a potential solution. Shall we give that a try, team? Let's give that a try. Why don't we do that? Hell yeah. Um, Oh, no way. You think it's from this? That's interesting. What does this mean? I wonder if it means a file path that ends in Python, even if it's nested in a folder? Um, that's interesting. Well, shall we use ask? Well, we can actually use cursor too. We can shall we see what would happen? What would happen if this check became this? Yeah. Don't worry, Nick. If you've got some ideas, we gotta try it out. We learn by trying. And also, yeah, these quotas are biting us, aren't they? So no worries, use my account as a guinea pig. I would be very happy to test this together. So if we used star, the extra star after the slash means one or more path segments before the file, so it matches Python files only when they're under at least one directory. Triggers for scripts generate test py. Oh, it's not trigger for app or any other Python file. I feel like that might do a bit of. Would that do damage for us? Will that mean like we wouldn't even trigger this workflow if what we've changed is the application file? Unfortunately, the application file is very important because that is the thing that should be triggering our workflow. Like earlier in this step, we were testing whether we could trigger this workflow by testing the application file. So I'd imagine if we were to change that condition, it would end up meaning that changing the application file wouldn't even, trigger the workflow in the first place. So that seems like that might actually stop the workflow from running. So maybe we have to consider a different path. But this is very interesting, Nick. I like the way you think. Let's have a think about Amelia's suggestion about changing a line. Let's see what Cursor would say if we just try to share our concerns with dear Cursor. Okay, so how we could do this is we could highlight this, press Command L, which automatically copies the lines that you've highlighted as context for the chat message. So we are going to ask Cursor, hey man, this workflow is passing. This workflow is currently passing, but something is happening. What is happening? But even though there are changes to Python files in the PR, no new tests are generated, gets triggered. How could this be? Dear Cursor, what do we think has happened? So let's see. I'm so suspicious of this git diff dash dash quiet test thing. I am so suspicious of this thing. I'm like, are we supposed to say if this equals 1 or if this equals 0? Then we go echo? Because what we've learned from ask is that it exits with the status of 0 if there are no differences. So if we just leave it like this, does that mean we are actually saying no new tests are generated when it's successful? Does this say that it gets triggered when it's successful or when it's failed? Like I'm not too sure yet. Like I think that is a big unknown at the moment. And I think that's why I feel so suspicious of this line. All right, guys, I'm gonna bet $10 on this one. No, I don't know. I'm not too sure. I shouldn't be betting some money on the stream. What do you think? What do you think? What do you think is the culprit, team? Roy says you called $10. On what? Do we have the same hypothesis, Roy? Are you also suspicious of line 52? Line 52 is our main suspect. Um, although this is based on gut feel at the moment. It could be completely wrong. So let's see. Oh. Interesting. How Git spaces specs work for pi. Whoa. All right. We're doing something. Yo. Yo. There's some changes that are happening. But look, this is the hypothesis that Nick also had. It's I think Nick, I think you're right. Okay, let's dig into this. I think it stopped generating changes. Okay. Let's do it. Let's have a read. So Cursor is suggesting something. We don't know if Cursor's right. So dear Cursor, thank you so much for the response, and we will test this. So base branch is not fetched. Okay, so this is something to do with our Git operations. The second thing is commit step runs when generation was skipped. Commit generated test has no if and always runs. When generate test is skipped, it still runs and reports no new test generated. Okay, does that solve our question? It feels like it's solving something else. In the scenario where there's an empty file list. Fetching the base branch before the diff using explicit recursive path spec for Python files and making the commit step run only when generation ran. Okay. So we've got a few changes. I'm very curious about what's going on with this like file path thing, by the way. The 2 stars and then another one, another asterisk before the Python. Path spec might miss subdirectories. Files like AI review wouldn't be included. Hmm. Hmm. Okay, we've got a few things going on here. So we've got something like switching the path spec and only run commit generated tests when there were files to process. This seems like a good one. Although the workflow seems to suggest that we already had files to process now, with analyzing like different files and then generating tests and then writing them here. So would it make sense if we were to try run all of this locally and then just see outputs and see whether or not something's going on with the scripts themselves? Because I guess there could be two things that are wrong. It could be either generate tests that's wrong, something's going on here, or the workflow file. So I feel like if we could do everything locally, does that mean it's definitely a workflow file issue? I don't know. These are all open thoughts. Let's see. Why don't we just, would it be silly if I just did this right now? Python run I'm gonna try activate the virtual environment. Let's just see what's gonna happen if I try run everything locally. Is it supposed to run locally? Really? Okay. Okay. Let's give it a go. You never know what might happen. Activate. Is there a command for activating our virtual environment here? Let's ask. What is the mat command for activating our virtual environment? Concise. um, ooh, you can also, Panel says you can also try adding the git add before the git diff check. Git might not be able to see the new file. So we're suspicious that this could be a git problem. Interesting. Okay. Try adding the git add before the git diff. Right. So git diff would look empty if nothing was added. Which is a very valid thought. So this is the this is what Amelia was suggesting, eh? Like the lines that Amelia had to change. Okay, so I understand now. So for Amelia's change, what had happened is we actually git add first, so we're staging changes, and then we run git dev to properly check for changes. Okay, so why don't we do that and put git add here. Okay. Okay. All right. I think we've got a few pathways, and my head's like, oh, which one do we want to test first? Do we want to test running things locally first, or just test like the git add thing? My curiosity is like, it keeps saying like, test it locally, just run it. So please be patient with me. Not too sure how this is gonna go, but really keen to just run this here and just see what happens. I'm super curious on what's gonna happen. So shall we just give that a go? Is this gonna run? Oh, okay, maybe it's not gonna run. Maybe I shouldn't have done that. Oh, because we don't have an environment variable for Gemini API key. Okay, that makes sense. That makes a lot of sense. Yeah, we would need to do that, don't we? Okay. Okay. Well, I was super keen on running this locally, but maybe we won't do it today. Maybe we will try putting git add above the git diff. And I'm gonna undo these changes. It doesn't feel right to do these changes without really knowing what's going on here. Although the fetch base branch seems interesting, like we're always fetching what's in the main. But anyway, let's just undo those so that we're testing things one at a time. And we're going to start by testing what happens if we were to just add these tests first. And then we check for the git diff. Cursor is seems to be trying to give me a little hint by giving me an exclamation mark. But I'm not too sure what that's gonna mean, so we'll leave it for now. So let's git add, git commit. The only change we've done is move up git add tests to go before git diff. I think that's the only file I've changed, although this suggests something else. We'll just push that. Oh, what's going on here? Oh, yeah. Okay. Cool. Let's see. Oh, Nick is also convinced that maybe introducing the step to fetch the base branch reference first is the way to go. Yeah, maybe that's it. Okay, let's do things one at a time. To be honest, time is our friend, not our enemy. We will try this one at a time. So let's go ahead with checking out add factorial function. PR, a trusty PR, and see what happens in this run of generate tests. Let's give it a go. It's going to be about 2 minutes, heads up, for us to run this every time. So why don't we also just do a bit of exploring in the project? I'd be very keen to do a secret mission kind of preview to see what's going on while we wait for that to load. So let's see what's going on here. By now, you've built a test generation bot that creates tests for new code and commits them to pull requests. In the secret mission, you'll make it smarter. Your bot will only run when coverage will drop below 80%, saving API calls and keeping your CI pipeline efficient. Interesting. So we're now going to only generate tests when our existing GitHub Actions workflows would only when the coverage of our existing GitHub Actions workflows drop below 80%. Interesting. Because the theory is that if your GitHub Actions workflows are already covering 80% or more, sorry, I think I burped a little. If it covers 80% or more of the code, then you should be able to trust your GitHub Actions workflows. Like, you should be fine. But if your workflows only cover like less than 80% of the code, then you should use Gemini, call that API, get it to generate tests for you, and then see if it works. I see. That's a great preview of the secret mission. I wonder how it would work. Yeah, interesting. How's everyone doing? Is Amelia, how are we doing, Amelia and Nick? Do you think, is the workflow running for you? Are tests getting generated for you right now? I'm so curious. I wonder how things are going for Shane. You know, for anyone that's doing this project live right now, are tests getting generated for us? Well, I mean, this is no new tests are generated for us. Okay. Okay, so we've got, actually, these commands are still getting run. Yeah, no new tests generated. Push and everything. Okay. Should we just have a go at the other suggestion that Nick was thinking about? Oh, Shane is doing your summary. You're almost done. Well done. So does that mean the tests are getting generated for you? That's amazing. And well done, Amelia. You got it to work. I mean, it's a lot. Well, I guess that tells us that it was, you know, that the error that we ran into is something that requires a meaningful change, you know, for us to be able to fix it. So this is Amelia's fix. Super curious how that went for you. And it looks like, wow. I mean, it looks like you've got GitHub Actions going. Oh, yes, I see. So we've got a bunch of like code updates for Amelia. Wow. Cool. Okay, yeah, so I'm seeing a few changes in both files. And look, you've got the tests that were generated for your code. Aw, Roy, thank you so much. I'm glad you enjoyed the interactive build lab. I'll see you. And yeah, it is a pretty spicy one, but I'm glad we could do it together. It makes it so much fun. Thanks, Roy, and I hope you enjoyed this project too. All the best for yours. And we'll see your documentation, okay? Yeah, but, you know oh, okay. It's bedtime for Nick as well. Ah, this was a lot of fun for me too, so thank you so much. Your presence was on point. Thank you very much, Nick, and see you next time. Bye. Alright. Good night, everyone. Good night, Sahib. Thank you so much for joining us today. Oh my gosh, Sean has Nat DJing up some AI gen testing mixes. Oh my gosh. What is happening? Should we open this? I'm scared. I'm so scared. Um, let's see. Whoa, 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 whoa. That's so sweet of you, Sean. You're using your remaining credits of this for us. You're so sweet. That's so funny. Shall we open this up? Oh my god, I was not ready for that. Oh, oh my gosh. Yeah, I was not ready for that. My goodness. My goodness, what was that? Oh my gosh. Thank you very much, Sean. I actually needed that. That was a crazy boost. My goodness. Um, wow. Wow, that like opened my eyes to a different life, man. Okay. Um, back to our work here. Honestly, I'm so glad to see that Amelia could get it to work. And honestly, one of the things I'm noticing that is the same is is it the use of is it the fix that Cursor had initially suggested? It feels familiar. Um, this part, fetch the base branch before the diff. Yeah, I feel like we could use something here. Um, could we ask it to make this change? I feel like it's the first step. Ask it to make this change. Hmm. Okay, why don't we try that? Again, one step at a time. Let's see if this changes anything for us. So the fetch base branch step is in place again. It runs immediately after checkout and before setup Python. So let's see. Let's see if the changed Python files get picked up. Let's have a go at going git commit. Adding a step in testgen.yaml. Push that. See what happens, yeah? Um, okay. Let's see what happens now. So it might be another 2 minutes again for this to run and work, but that's okay. Let's have a look at our secret mission again. Um, oh, cool. Yeah, looks like this secret mission would be about helping us check for coverage, and helping us decide whether or not we would skip test generation or do test generation, depending on how much is already covered from existing workflows. Um, okay, so we've got a script, check coverage, Python file, and then we're gonna add some code to that that will help us check whether or not 80% is already covered by existing workflows. Mm. And then we'll update the workflow to add coverage checking. Let's see. Hmm. We're gonna commit those tests. Gonna test the coverage gate. Ah, okay. Add the function, and then commit and push the work. And then we'll create a PR to try trigger it. And then we're gonna see that coverage is dropping below 80%. So AI will generate tests for the new function. Okay. Well, that's very, very interesting secret mission. Shane, did you get to do the secret mission too? Well done, if so. So interesting. Wow, you've done the secret mission as well, Shane. Did you end up fixing your project files to get it to work? Or did you just run it as is and it still worked for you? Super curious, man. And congrats. Okay, very nice. Ah, you've had a few fixes too. Ooh, would you be happy to share what fixes you made? Super curious on how you fixed it. Um, is it the same kinds of fixes as Amelia's? So if you don't mind sharing like the PR that you used to fix it, we'd love to check it out. That'd be awesome. We can learn from how you did it. Oh yeah, and Amelia's on a secret mission now too. The CI workflow that builds the package broke for me, so I'm trying to fix it right now. Ooh, fingers crossed. You're almost there. That's awesome. Okay. Yeah, it seems like no new tests are generated still. So the error is probably a little bit deeper than what I've been crossing my fingers for. Like, I've been hoping that it will just be a very, very simple kind of fix, but maybe it is a little bit deeper. And that's okay. That's okay. Jane, I'd be very curious to know how you did yours. So that before I go straight into like, all right, let's go full file change mode. If there was a version that didn't require so many file changes, that'd be very interesting. But in the meantime, let's have a look at what really could be causing no new tests generated. Hmm. Um, honestly, this is the part where I would actually mention that it says this workflow should be triggered by a change to app.python. The PR does include a change to app.python. Hmm. The, the message keeps saying no new test generated. What could be the reason? Hmm. I wonder. I wonder. That's all good. Shall we keep on going with the curious on whether or not we could do a cheeky head start for this question on what were the key tools and concepts you learned. So if we could preload a little bit of these final few questions. All right, key tools we used include, very quickly, we know that we use GitHub Actions. And key concepts, oh, we also use Gemini, so Google AI Studio. And then key concepts we learned, oh, we learned a lot today. We learned about the structure of a GitHub Actions workflow, i.e. trigger on pull request, where with specific conditions for the files changed. And we also learned about, that's what we learned about recursive. And what else did we learn? Recursive functions. We'll leave it there for now. Because we've got an update here, it says tracing the workflow and scripts to find why no new test generated appears when the application file changes. Check the commit step. The order of operations may be wrong. The commit step runs git add test before checking for changes. After staging, git diff quiet compares working tree to index, so it's always true and we always hit no new test generated. Checking for changes before staging and fixing the logic. So it was totally fine then that git add test was at the bottom of the file. I remember manually moving it up, but that actually might have made things worse instead of better. Okay. Okay. So the changes this is really making is just making sure that the order of operations are right. Because right now it's not correct because we are adding, I moved this add up when actually it should have been at the bottom where it originally was. And here it's trying to say that it should also be triggered by other files that were changed, not just files in the root of our project, not just the Python files in the root of our project. So I can see a little change there too. And now it's going to start outputting a list of all of the changed Python files for clarity as well. So honestly, I don't think this is actually going to make a material difference based off of like my first instinct. But perhaps it's making that back to the bottom. So let's have a go. Git add, git commit, update the order of operations. And then we push that. Maya says, I was away and now I'm back and we're still going. Go Nat! Thank you so much. Oh, I saw a comment from Amar. Never too late, bro. Amar says, man, I'm late. No, you're not. Never too late. Never too late. Just glad to have you here. Yeah, did you see that DJ Nat video? Whoa, I was shook. I was shook. I was not prepared for that. Okay. Well, we've just accepted a bunch of changes from Dear Cursor, so we'll put that to the test, see if that actually makes things work for us. And in the meantime, I think has Sean done the project? No, actually no, Sean's just made a comment. Just a guess, but could it be creating a branch instead of the main? Like something like this, because this is what I'm experiencing also. Origin feature new function. Could it be creating a branch instead of the main? Yeah, I'd hope that these tests still work even in a branch instead of needing like the changes to be in main. Is that kind of what you're thinking of? I merged it. So oh, Shy Sinister. Oh, sorry, I'm like scrolling. Ah, okay. So we've got Shane. Thank you so much, Shane. Putting in the chat their GitHub repo. So we can check out Shane's work as well. So shout out to you, my friend. Well done. Whoa, you've got some cool things going on here. It looks like you've also had a bunch of tries. And we've got add factorial function that worked. Nice work. And it says AI test generation. We want to do AI test generation and see if it works. So let's give it a go. Let's see. What do we think, everyone? Generate tests eventually worked for you, and I'd imagine it's around here. Oh no, it's actually not here. Maybe in the next one that tests were generated. Oh my god, I'm like in so much suspense right now. I wonder when I will get to solve it for myself too. Okay. Let's see. It's still running. It usually resolves itself in 3.5 minutes. So let's see if it's gonna work out. In the meantime, let's quickly smash this one out. What are some other key concepts that we learned? We also learned how to verify tests, run automatically, building and test generation. Oh yeah. And how to create a test generation. That's great. That was great. That was awesome. Ooh, yeah, we'll leave the rest for later. Awesome. Okay. What do we think, team? Oh, it worked. Hmm. This is reporting to everyone that in round 4 of testing this, I think we've got it to work. Wow. Yeah, we generated a new test. Oh, amazing. Well, that's cool. Yay. Oh, that's so cool, everyone. I think it's finally working. Oh, that's amazing. Thanks, everyone. It's so good to make it to this point with you all. Let's go back to our task. Okay, so as you can see, we can confirm that it's working for 2 reasons. First, in our pull request, you can scroll down and you can see that we've got no conflicts with base branch. You know, we can merge this. Okay, that's great. But more importantly, hey, where is our GitHub Actions workflow? Hello? Hello? Maybe not here. Maybe here. Yeah, we can see that the GitHub Actions workflow, all 3 of them passed. So CI, AI test generation, and AI code review all passed. That's great news. And the problem that we kept running into was that within AI test generation, the workflow would pass, but it wouldn't actually do its job. So it would finish running. It would say like, okay, I finished running. But then when you check its work, it was like opening an empty shell. Like we clicked in this, Amelia and Nick both called it out. Hey, it could succeed, but if you click on commit generated tests, it had a problem where it kept saying like there were no tests that were generated, even though it should have generated tests. So it wasn't fulfilling its job. Like this was the kind of output that we were dealing with, and it wasn't what we wanted to see. Okay, no new test generated. That was not a good sign. It actually suggested that the entire script that we wrote about generating tests just wasn't used at all. So we fixed this, okay, and we can see now that it's been fixed because now when we see the output, it doesn't say no new test generated. It tells us that it has committed a test. In fact, we can even find it in our code probably. We can probably find it in the pull request. A new file that's been changed. Let's check it out. Yeah, there we go. So you can see the entire test file that's been generated by Dear Gemini. And a test has probably been generated for every single function in our code. So that's great news. It did take a little bit of trialing and testing to get us there, and this is a great diff for us to just review those changes. So some of the things that we had to change, this is irrelevant. This is stuff that we had to change, like general troubleshooting. But the key things that we had to change was actually inside the GitHub Actions workflow file. One of the problems was that for this, for some reason, this seemed to be passing, or it seemed to be suggesting that no new tests were generated, which is the reason why we would just exit without committing and pushing files. Honestly, this is still pretty new to me. I'm not too sure what this does that git diff isn't doing, so it'd be good to understand that part. And to Nick's suggestion, there was also maybe we should use file paths that include Python files that are nested in subdirectories and subfolders so that they are included in the Python files that have been changed. Now, initially, I was suspicious about this. I was like, oh, I'm not too sure if that's going to solve the problem because adding this new file path checker wouldn't have changed the fact that at least this app Python file should have been picked up. Like this file should have triggered something. But again, it didn't get triggered, and adding this wouldn't have changed it because the app file like matches this requirement. But we added it because when I was kind of troubleshooting with Cursor, this was one of the main suggestions too. So it'd be interesting to understand which change has truly changed things for us. It wasn't this, which I thought would have changed things, which was to fetch the base branch, the main branch, and make that the base branch instead of using this remote branch that we've been working on, which is like feature/new function. This didn't seem to change much because we only just made this change on its own, and we tried to rerun our workflow, but for some reason it was still failing for the same reasons, so it didn't seem like it made much of a difference. So it seems like one of these changes, probably this one, my money is always on the fact that this line is something's off about this line, and we're finally checking it in a way that makes sense. Maybe that's what happened. Honestly, this line could have made a big difference too, because let's actually try to understand what change this line brought about. Steps not changed. So let's actually put this in a chat so that we can understand what this change means. Can you please explain? Can you please explain why we added this line? Did it contribute to the workflow? Finally generating tests? Let's see what happens. Okay. Okay, so this is basically I don't think this line actually fixed any bugs. It was just making sure that we only run the workflow. We only run test generation when there are changed Python files. So it feels like I don't know if that would have changed much. I wonder. I wonder if it did. I don't. It seems like it didn't change too much because we'd always had changes to our Python files. So this would have blocked things from happening. But in this case, the error that we were trying to see, we were trying to allow something to happen, and it was being blocked for some reason. So maybe this line has something to do with it. Yeah, honestly, this line doesn't seem like it made much of an impact either because reading it, this line is what makes the workflow only commit and push when there are real changes under tests. Um, yeah, this wouldn't have been the reason why we can suddenly generate tests either. Um, actually, knowing that the error or the issue was probably that we just weren't generating tests, the changes above this line where we call generate tests is probably the like anything above it is probably what made a difference. Hmm. Maybe it was this line after all then. Maybe it was the line that I was always suspicious of, like suspicious that it wasn't contributing too much. Let's just quickly check that. What about this line? So curious now. Um, hmm. So here it's telling us that, oh my gosh, it actually could have been this line because it's telling us that without line 40, you'd have no list of files to generate tests for. Hmm. So maybe that made a real difference, like making sure that there was a list of Python files that we could generate tests for. Having said that, we did already have an original line doing that job. We were just improving that line instead of like writing it from scratch. So, yeah, feeling a little bit suspicious of that one too. Yeah. So, I have a feeling this is still a bit of a mystery, isn't it? Mm, hmm. What could be the reason why we are generating um we are generating tests in the test folder now. Before we previously we weren't. Well, yeah. Um it just suddenly came to mind that honestly, it could have been because we finally moved this back down as well. Because I moved it up and maybe what that meant was like we had two issues. I mean, we had one issue, we solved that issue, and at the same time we introduced a new issue when I brought this up. But I shouldn't have. So when we finally brought this line back down, like everything finally clicked into place because the other issue's been solved. Now this one's been like back to what it should be. So finally everything works. Um, I'm starting to wonder whether that was the reason as well. Yeah, there are lots of potential like points of error, you know, in this one workflow file. Um, so it's good to see it all summarized in this table here. Hmm. In the meantime, we've got Amar with a great question. Cursor over Claude? Personally, I just prefer Cursor, but honestly, Claude is absolutely amazing, like a fantastic tool. And the whole team uses Claude as well. So I would say between the two, it really comes down to your own preferences for UI and different kinds of features that they provide. But in terms of accuracy, I wouldn't say that they're too like different. Um, Claude's skills and some of its features though are pretty cool, pretty standout. Um, so it probably comes down to the kind of like different kinds of UI and interaction features that you like. that can help you with deciding between Cursor and Claude Code. Awesome. So honestly, it's a pretty interesting experience doing this project because I feel like we've kind of gotten to an answer for what went wrong and how we fixed it, but it wasn't very black and white. You know, there was a lot of experimenting, and obviously we got there in the end, which is great. The clarity, though, is something that I can imagine is still something we're like not too sure about yet, which is totally fine. Sometimes you just have to see a pattern happen a few times before you have that confidence, and that's totally okay. Awesome. Okay, so I know we're like pretty much an hour and 30 minutes over time, so I'd imagine we might not have enough time to do the secret mission today. But how's everyone doing? Like, is someone really wanting to do the secret mission together? Because, you know, if that's the case, why don't we stay for longer and do the secret mission? I think I think that's a great idea too. But otherwise, like, totally get if this has been if we are happy to wrap it up here. Cool. I'll just let you guys put in your thoughts in the chat on how you like to do the, I guess, like the last secret mission of this project. Whether you like to do it in the lab or outside of it. Cool. All right. So how do you know the test generation bot is working? The bot generated tests by running generate tests by running the generate test function on every single function that are extract functions that we've collected. The bot generated tests by running the generate test function on every single function within the files that have changed. You know, i.e. at I especially. This one's important to know. The commit shows, well, the commit shows a new generated test file, a newly generated test file. This verifies that, well, what does this verify for us? This verifies that the test file or the test scripts were actually generated by Gemini. We ran into multiple errors where the GitHub Actions workflow worked, but didn't actually generate tests or scripts for us. Okay, cool. All right. So it seems like we're a little unsure about our secret mission today, but that's totally okay. Shout out to Ama for saying, I mean, of course, Claude, but do you have any workflows to use both together? Claude and Cursor. Well, Claude and Cursor, have we seen anyone actually use both? To be honest, I have seen people use Claude for kind of like the main commands that they've set up. And then they use Cursor because it's very intuitive in terms of just being able to highlight, press Command L on your keyboard, and then comment on minute changes you want to make. But you know, if you're generating like a lot of code from scratch or you have a big like command, then people really like to use Claude for it. And then Cursor for any touch-ups or any like cosmetic changes. So that's what I've been seeing mostly. Okay. Wow, okay. So we do have our secret mission here. I don't see anyone messaging about it, but we can always just do a quick run through of it just to see like how it works, honestly, because it's always worth learning. It's always worth learning more. So let's have a go. Only generate tests when coverage drops. So this secret mission is about only creating a condition so that we're only using Gemini AI to create tests if our existing workflows only cover like less than 80%. Less than 80% of the code. So let's have a go at this. In this mission, in the secret mission, we're going to set up what's it called? Coverage gated tests. By creating a coverage measurement in the repo. This saves API costs as it makes sure that we only use Gemini AI, like the Gemini API, to generate tests for us when when coverage is below 80%, i.e., when the API costs will be worth it. Okay, so we're going to just make sure that in the requirements file, we're going to add this plugin that measures code coverage, the percentage of your code that's executed by tests. It tracks which lines run during test execution. Well, that's awesome. Really glad to know that there is actually a plugin that already helps us with measuring code coverage. I feel like that's like half of the challenge already solved for us. So shout out to PyTest Cove. And we're going to go ahead and create that script that helps us with checking coverage. It's under scripts. So let's create a new file, call it check coverage Python. Okay, and then we're going to go ahead and add this code into here. Okay, so we've got a bunch of code and we've got some new Python concepts that are introduced in them, like using sub-processes or capture output, so that we're capturing things like standard output instead of printing to terminal. We could return output as strings, we could parse a JSON file, we could exit a program. Okay, we could like get the first command line argument. So there are a few kind of little bits and pieces about using Python that's introduced in this code. And here is what the complete code file will look like. The important part is that truly we need to pick up that less than 80% of the code is run by scripts. So this seems to just check for the threshold, check coverage and exit with the appropriate code. Yeah, very interesting. Okay, so let's copy this code and let's paste that in check coverage Python. And then we're going to go ahead, now that we've saved the file, we're going to take a screenshot of our coverage check script and then let us answer invalidation. Let us answer a task. So let's go ahead and put that screenshot in here. And let's answer this question. The script measures coverage by using the plugin called, what is it called again? Something code. PyTest code. It exits with code 0, so which is success, when coverage is beyond 80%, and code 1, failure, when coverage is beneath 80%. Okay, I'm just gonna double check. Yeah, so success, coverage is good, skip test generation. Nice. Okay, So we now know that the script will run PyTest with coverage measurement. It will read a coverage report. It will compare it against that 80% threshold, and then it will decide whether or not it's going to exit with success, which means we can skip test generation, or failure, which means we should go through with test generation. So now let's update the workflow to add that coverage checking. So we already have our workflow that's called, let's see, it's called test gen. But in this case, we're just gonna add that coverage checking kind of condition. So find the install dependency step. So we've got that here, and then we're gonna add these two new steps directly after it. So these two new steps needs to go directly beneath it. The first one is about checking the coverage threshold, checking whether or not it's 80%. If it's not 80%, maybe it's higher. And then now that we've added that, we're going to add some conditions to the remaining steps. So we're going to find get changed Python files. Cool, it was right here. And add the if line. So if steps coverage check outcome is failure. So if we are beneath the threshold, we are at 80% or less. Okay, cool. And then it says that we should find generate tests and update its if to include both conditions. So both the condition of both the condition of failure, which means we should generate tests. Okay. So now it has two things that it needs to pass. One being like the files that have changed are the Python files that are not inside the tests subdirectory. And the other thing we need to test is to make sure that the coverage of existing workflows is beneath 80%. So we've got two things to check for now. And both things need to say like, yes, you do need to generate tests for us to actually go ahead and generate it. So we're going to find the commit generated test line over here. And then we are also going to say, hey, if the outcome is failure, if the outcome for the coverage check is failure, then you definitely should be committing your generated test too. Okay, interesting. So why don't we go on ahead and create that new branch for us, and then see whether or not we get to run this updated workflow. So we've got a command for creating a new branch. It's for the untested function. Interesting. And then let's create a new file called more utils. Okay, so here we're going to create a file. Let's name it more_utils Python. Okay, and then we're going to add this function about checking if a string is a palindrome. Oh, do you like palindromes? You know what they are? Palindromes are awesome. It's when something spells the same like back to front, eh? What is it? Dad. Dad is a palindrome. Whoa, we got two people with palindromes already. Civic and race car. Oh, race car. Wow. I never thought of civic as a palindrome because the C's are pronounced so differently. Yeah, they make such different sounds. That's so true. Okay, and then let's go ahead and commit and push the palindrome checker. So we are deliberately not adding tests for the palindrome function because this will just make sure that coverage for the code base will drop below 80%. And we need it to drop below 80% because if it doesn't drop below 80%, then we don't get to see our test generation actually getting triggered and running. That's the important thing we really need to check. So now that we've pushed let's go ahead and create a PR that lets us over here. It's a PR that lets us just check. Hmm. Let's see. I see. I wonder what's gonna happen. All right. So we're gonna watch the coverage gate in action. We're gonna go to the PR on GitHub. We're gonna see that coverage should drop below 80% for the amount of the code that isn't tested. And then we're going to see AI generate tests for the new function. So it should be generating tests for is palindrome automatically for us. Let's see if it does that, eh? The bot should even commit the tests that it created. Again, making sure that we should skip the CI, shouldn't we? Okay. Oh, this is interesting. Ooh, let's see what it does. So excited. Were we supposed to merge our pull request for the previous step, by the way? I don't think so. Oh, no. I don't think we were supposed to merge. So we should be fine. I was worried that we were supposed to merge, and because I didn't, it might mess up our work for the secret mission. It seems like we're okay. Okay, so that's a good thing. So why don't we check on our lovely GitHub Actions workflow and see if it has been triggered and if the coverage test is working correctly. Let's have a look, yeah? Let's see. Ooh, got a problem. No. Oh yeah. See, I built is failing. I have a feeling Amelia had the same problem. Is this the exact same error message for you? Oh, we're having the same problem. Multiple top-level modules discovered in a flat layout. More utils. Backend subprocess exited when trying to invoke get requires for build. Could it be something to do with our requirements file? Is it missing something? PyTest cov? Like we added that. Could it be that? What do you think? What's going on here? What could this error be triggered from? I wonder if it's to do with PyTest cov getting added to our requirements. Because get requires for build sounds like it was something happened when we were trying to gather requirements. Let's see what happened. Why did we get this error? Amelia too. Well, aside from this, the other workflow files, the other actions files run correctly? Let's see. Actions. Okay, so it's only the CI that seems off, but test generation ran. And let's see, commit generated tests, and it actually generated a test. So at least coverage checking is right. Like that's correct. It's just that we have a few other errors on the CI file, which, it's just like an unfortunate victim, like just caught in some of the changes that we made in other parts of our app. Didn't seem like it would have been a problem but once we added new modules, other files needed to be updated to reflect the new modules we were using. Yeah, so the project has both app and more utils at the repo root. With a flat layout and no explicit config, setup tools discovers all top-level Python modules and it refuses to guess when there's more than one, so it fails. So because we added a new file in the root, which was more utils, that contributed to the failure. Oh, so interesting. Well, at least we've fixed that now, so it honestly should be okay. And it seems like the build is fine now, so we actually should be able to just commit this and have a go. Update my project. Let's have a go. Let's see if it's working now. Updates were rejected. Okay. Because the remote contains work that you do not have locally. Oh, okay. Maya's got to step away. Thanks for the heads up, Maya. That's all good. Let's see. I wonder if this is caused by... Oh, could it be because the bot is also committing to this? It committed a file? So maybe it needs to get pulled? Because the bot already committed a new file, which was the generated test. So yeah, we have divergent branches now. Oops. Well, this is a little bit this is a bit unfortunate. That's okay. Why don't we try do a merge between the two? Let's see what would happen if we did that. Yeah, okay, so we've merged now. Great. Let's see if that means that we'll be able to just push all our changes. But basically because our bot also created a new file and committed it to this repo, it meant that our local repo was no longer actually up to date with all of the changes in the remote. So we needed to do a few like git related operations, make sure the pull the file that the bot had just committed. So let's see. Yeah, this build is still failing though. One error during collection. Well, at least we've got a new error now. Test generated invalid syntax. So it seems like there is some sort of syntax problem in the generated test. Which is the reason why build failed. Oh wow, so it feels like we've got a quality issue now. Because it actually generated the Python test using like code block formatting. We probably didn't need that. Do we need that? I don't think so. Surely not. Let's see if we can just manually resolve this. I feel like we should be able to go into test and let's go into that test generated file. This was the generated test from Dear Gemini. And clearly this like triple backtick thing is causing triggering some sort of error, invalid syntax. So my guess is we should be able to actually just say, hey, like let's just resolve the syntax error, and then we should be able to push this, and then the build should work. That's the guess. What do you guys think? Do you guys have confidence in this? Treats the backticks as invalid syntax, yeah. I don't think we need this at all. We should probably be able to delete like lines 1 to 4 and then delete this closing set of triple backticks. I'd imagine that's enough. That's probably all we need to do. But let's see. Let's see if there's something else I've missed. Oh, okay. There is more that I've missed. Yeah, okay. Yeah, there are a lot of markdown code fences, it seems. Because every single test that it generated, it tried to put those tests inside the triple backticks. But it seems like it treated this Python file as a markdown file when actually it's a Python file. So because of that, it wouldn't build correctly. Perhaps the intention was actually this is supposed to be a Python file, but then it's saved as a it was supposed to be a markdown file, but it's saved as a Python file. Like, if it was just saved as a markdown file, I think we'd be fine. It's just that the test probably wouldn't run, which would be unfortunate. But it seems like... Yeah, Amelia says this is the same error from earlier. I changed the prompt in generate test to include output rules. Ah, that's a great way to do it. Like the generate test script, you added output rules. Do not use markdown. Do not wrap code in triple backticks. Output must be a valid Python file content. Yeah, that's excellent work, Amelia. Yeah, that is such a good idea. I'm honestly gonna write this down as a note to improve the secret mission. Because we should definitely do that. Yeah. To not use markdown. Because clearly, your Gemini generated like markdown content inside a